Okay, so we're going to move on to the mole now. Now, you would have done a little bit about this at GCSE, but we're going to recap and do a little bit more at AS. Now, let's say I want to do this reaction. I want to take iron and react it with sulfur to make iron sulfide. Should be quite straightforward. But how would I go about doing that in the lab? How do I measure out how many ions I need and how many sulfurs I need? Can I just say, oh well, I use 10 grams of iron and 10 grams of sulfur because it's a one-to-one reaction? I can't, because iron atoms weigh a different amount to sulfur atoms. So you can't just use masses to work this out. And instead, we use something called the mole, which always kind of freaks people out because you think of little furry creatures, things like that. But it's something completely different.
Is this when you do the table and then you work out and then you sort of like divide them and then you find the smallest and divide them by the smallest and you go?
Not quite. We're going to do something similar to that in a minute, but we'll do it. So, how do you do it? Well, atoms are too small to see. They're tiny, tiny, tiny little things. So I could say, well, I'm going to take one atom of that, react with one atom to that, and I'd make 1 unit of that. However, it's too small to see, so we use moles because in a test tube we've got billions and billions of atoms, so we have to use this thing called the mole because it works on a big scale. Does anybody know a definition or have an idea about what I mean when I talk about a mole? Yeah, the mole is the a mole of anything contains 6 times 10 to the 23 of it. So I could have a mole of people, in which I've got 6, followed by 23 zeros, people. I could have a mole of humbugs, sweets, where I'd have that. A mole of M&Ms, it would be exactly the same. Now, we wouldn't talk about the mole in that sort of in everyday use, because it'd just be too many. You know, we'd never cope with such a big scale. But we can when we talk about atoms. So, for example, I have got in this container a mole of sulfur atoms. And in here, I've got a mole of iron atoms, like so. And then finally, in this one, I've got a mole of carbon. Each of these jars contains the same number of atoms. This one is a mole of iron atoms. So in here, I've got 6 times 10 to the 23 iron atoms. Here, I've got 6 times 10 to the 23 sulfur atoms. And in here, 6 times 10 to the 23 carbon atoms. And this is a really useful tool. Working with the mole is like a basic chemist toolkit. You need to be able to understand the mole if we're going to be able to do all the rest of the calculations coming up in the course. So if you get stuck on this, please let me know. So how do we define the mole? Well, really the mole is just a unit of measurement. It's a number. We're just going to think of it as a number. And we're going to talk about it as the number of atoms in 12 grams of carbon 12. What do I mean when I talk about carbon 12? Rather than just carbon, why would I call it carbon 12?
That's an isotope of carbon.
Brilliant. And what type? What if I was to draw out a big C?
Having 12 in the top left.
Cool. And 6 there. So that's my atomic number there, and that's my mass number there. So that isotope has got 6 protons and 6 neutrons. Okay, so we're just going to write a little bit about this out. So we'll do the mole. I'll get rid of that. And we'll just do, so this is, so one atom of any element is too small to see. And impossible to weigh out using our skills. So to count atoms, chemists use large numbers of them. control is called a mole. And it's just a number. You may, sometimes people talk about a dozen of things, it just means 12. A mole just means 6 times 10 to the 23. Called a mole, 6. Actually, it's on your yellow sheet. Ta-da. If you look on your yellow sheet, it's on the back page. There it's called Avogadro's constant. 6.02 times 10 to the 23. Because sometimes they like you to use that.
So we get given that bit.
Yep, that's on your data sheet. So we say a mole of a substance contains Avogadro's constant of particles. Which equals 6.02 times 10. And we'll just say the mole is used as the unit for the amount of substance. But the main thing is just think of it as a number, just a very, very big number. So, just one further definition, molar mass is the mass per mole of a substance. And that's measured in grams per mole. And you can find, where would you look to find the molar mass? Sorry? Yeah. The molar mass of an element from the periodic table. The relative atomic mass is the same number as the molar mass. E.g., if I want 1 mole of sulfur atoms, I need, skip over to your periodic table, have a look on your periodic table, sulfur is 32.1. So I need 32.1 grams of it. Sometimes we don't want 1 mole. I mean, it'd be bonkers to always have to use 1 mole of everything, to have to use 32.1 grams of sulfur. We'd get through the sulfur like there's no tomorrow, bankrupt the school. So sometimes we want to use half a mole. We don't want to use quite that much. So we need to be able to work that out from an equation, and it's easy peasy. So the number of moles that you have is equal to the mass that you weighed out in grams divided by the molar mass, which you can work out from the periodic table. Do you guys like oh. Okay, so moles, mass is up there, and molar mass So you can rearrange that as you like. Sometimes, rather than number of moles you'll be working out mass. So if I wanted to work out mass, it would be moles times molar mass.